Before we do our first difference quotient problem, one of the prerequisite skills is to be able to FOIL stuff. So real quick, let's FOIL x plus 3 squared. If you remember how to do that, you can rewrite this as x plus 3 times x plus 3, and then you FOIL it. First, outer, inner, last. Other people, they like to do a Punnett. Let's do the FOIL method first. X times x is x squared. That was the first. The outer is x times 3. That's going to be plus 3x. The inner is going to be 3 times x. That's going to be plus 3x. And then the last is going to be the last numbers times each other. 3 times 3 plus 9. And then you combine them to get x squared plus 6x plus 9. Another way to FOIL stuff would be to FOIL it using a Punnett square. So let's try x plus 4, the quantity squared, using a Punnett. That would be done like this. I set up my little Punnett, 4 square Punnett. So x plus 4 times x plus 4. X times x is x squared. X times 4 is 4x. 4 times x is 4x. 4 times 4 is 16. I'm going to combine on the diagonal. That usually happens with the Punnett. That's one of the reasons why I like them. So this is actually going to equal x squared plus 8x plus 16. Now we're going to FOIL out just something that's an expression, no numbers. So it's going to be x plus h, the quantity squared. If I were to FOIL that out, put it in a Punnett, it'll be x plus h times x plus h. X squared. H times x is hx. H times x is hx. H times h is h squared. I'm going to CLT, combine like terms. On the diagonal, how many hx's do I have? The answer is 2. So this is going to combine to equal x squared plus 2hx plus h squared. Pretty much, that's all we need to know how to do a big nasty difference quotient. All we need is a blank piece of paper. Write this down, evaluate. X squared minus 2x plus 5 using the difference quotient. Difference quotient, notice it has a quotient, which is a division bar, and a difference, which is a minus sign. This is just basically a fancy version of the slope. Y sub 2 minus y sub 1 over the difference of x's. The difference of x's is going to be h in this case. F of x equals x squared minus 2x plus 5. Let's set it up. First thing we want to do is draw a big division bar. Probably the biggest division bar you've ever drawn in your entire life. On the top, in the middle, we're going to put a minus sign. Underneath the minus sign, we're going to put an H. Hot che. Now, what do I put behind the minus sign? Notice what's behind the minus sign in the delivery is f of x. So f of x equals x squared minus 2x plus 5. So I'm going to put that behind the minus sign. And this is the biggest mistake made in any algebraic reasoning class, is just to put it like that. But I'm subtracting the entire quantity. So I have to wrap it up in parentheses. I'm going to need to distribute that negative sign across them. Now, what goes in front of the minus sign is a little high level. Wherever there's an x, I'm going to insert an x plus h. So up front, wherever there's an x, and there's 2 places, I'm going to insert an x plus h. So instead of writing x squared, I'm going to write a quantity squared. X squared, or a quantity squared, minus 2 times the quantity. Notice I got the 2 from that 2, and that's going to be a quantity, plus 5. Now I have to fill that quantity in. What do I put inside of these parentheses? And that's going to be this x plus h up here. That x plus h is going to go inside of the quantity. So I dump in the x plus h. Now, in order to evaluate it, I have a lot of algebra to do. So I want to set it up. I want to draw another big division bar with the minus sign over h. And now I have to expand out what x plus h squared. Does anybody remember what x plus h squared equals? And notice we already worked out in the prerequisite. The quantity x plus h squared equals x squared plus 2hx plus h squared. X squared plus 2hx plus h squared. So this FOILed out is x squared plus 2hx plus h squared. I want to distribute the negative 2. Negative 2x minus 2h. Now I have this plus 5 just falls down. I want to distribute this negative. Negative x squared minus. So it's going to be plus 2x. Distribute the negative, minus 5. Now I want to CLT. I'm going to combine like terms. If you'll take a look, you'll notice if I work from the back end that the negative 5 simplifies with the positive 5. They're going to go to 0. If you'll notice, the 2x, the positive 2x, simplifies over here with the negative 2x. That eliminates. It goes to 0. The negative x squared is going to eliminate with the positive x squared. So now I don't need such a big division bar. 2hx plus h squared minus 2h. Everything else simplified. All over h. Now, I can factor out an h from each term. Notice there's an h in each term. When I see this, I like to say, muchos h's. A lot of h's. Once I factor out that h, that's going to give me 2x plus h. Notice I divide that by h. Minus 2. All over h. What happens with the h's? They simplify. So the evaluation of my difference quotient is just going to be 2x plus h minus 2. So another difference quotient problem. The second one, we're going to evaluate 5x squared minus 6x using the difference quotient. This is the difference quotient, 5 times the quantity x plus h minus f of x, all divided by h, where f of x equals 5x squared minus 6x. Again, we're going to do a big division bar. Sobre h, over h, with the minus sign in the middle. What's behind the minus sign? What goes behind the minus sign? F of x. In this case, f of x equals 5x squared minus 6x. I'm going to wrap that up because I have to distribute the negative sign. What goes in front of the minus sign? What goes in front of the minus sign is the 5 times the quantity x plus h squared minus 6 times the quantity x plus h. I have to put in an x plus h in front of the minus sign. Notice I have an x plus h in front of the minus sign. So I'm going to set up a template. 5 times some quantity squared minus 6 times some quantity. And the question is, what goes in that quantity? The answer is x plus h. So I plump in the x plus h. X plus h. Now I have a lot of algebra to do. So big division bar. Sobre H. I have to FOIL this out first. I can't dump the 5 in distributive property before I FOIL out the x plus h squared. Remember, PEMDAS, parentheses, exponent, then multiplication or division. So I have to FOIL this out first. I wonder what the quantity x plus h squared is. Does anybody recall what the quantity x plus h squared is? Notice x plus h squared is going to equal x squared plus 2hx plus h squared. So I have to keep that 5 out in front, and then I FOIL this out to be x squared plus 2hx plus h squared. Close the parentheses. Now I'm going to do a lot of petty algebra. I'm going to start picking up the speed with the algebra. Distribute the -6, so that's minus 6x. Distribute the -6, minus 6h. Distribute the negative, minus 5x squared. Distribute the negative, plus 6x. Maybe I didn't need such a big division bar after all. I have a little bit more algebra to do. I have to distribute the 5 across this large quantity now. So big division bar over h, sobre h, 5x squared plus 10 h x 10hx. Distribute the 5 más 5h a la 2 plus 5h squared minus 6x minus 6h minus 5x a la 2 más 6x. I hope my Spanish is okay. Now I'm going to simplify it. When I simplify these big difference quotient, from experience, I know I'm going to work from the back end. So 6x simplifies with negative 6x. 5x squared, negative 5x squared simplifies with what's up front here, 5x squared. And that leaves me with 10hx plus 5h squared minus 6h all over h. Muchos h's, a lot of h's. I'm going to factor out the h. So I'm going to pull an h out of 10hx. And that would leave me just 10x. I'm going to pull one h out of 5h squared. That would leave me 5h. I'm going to pull an h out of negative 6h. That's going to leave me with negative 6 all over h. Let's check. If I distribute that h, that's going to give me h times 10x is 10hx. If I distribute that h to 5h, that's going to give me 5h squared. If I distribute that h to negative 6, that's going to give me negative 6h. The h's simplify, and my difference quotient is evaluated at 10x plus 5h minus 6. Those are two examples of moderately high-level difference quotient problems.